In this video, we'll do an example of solving a triangle using the law of cosines. And just a reminder that we want to use the law of cosines whenever we have a side angle side or a side side side. So looking at this triangle, notice that we have two sides given and one angle. And if you remember from last week, sometimes you can solve situations where you know two sides and one angle using the law of sines. But how I would think about it is if I think about the law of sines here, notice that I know this angle, but I don't know its respective side. I know this side, but not its angle, and this side, but not its angle. So if I was thinking about the law of sines, sine A over A, sine B over B, sine C over C, I don't actually know any of the pairs. And so this is a strong indication of when you want to use the law of cosines, because the law of sines will not help here. Because in each, we don't know any pair of the angles, and we kind of get stuck here. Because we only know one angle, we can't find the others. And we don't know the corresponding angles to the sides. So actually this triangle is not solvable with the law of sines. But with the law of cosines, if we think about what we know one angle and we know two sides, which is perfectly good for using these formulas, because in these formulas we have one angle and three sides. The third component should be solvable. And here we don't have anything labeled, and it implies that we want to solve the third remaining side of the triangle, which we could do by law of cosines. But let's just go ahead and call this A so since that's an angle, that should be capital A, and that would imply that x is little a. And let's just call this angle B and side B, and this side C and angle C. And remember that when you're using ABC, they must be corresponding to the angle and side, which are across from each other for these to work. If you don't do that, this formula will not work. It will not make sense. Same with the law of sines. But anyways, it doesn't really matter which is which, as I said, A, B, and C. And from here, we could start with the law of cosines, and this should be solvable. And if we're wondering, well, which version do we want to use? We want to use the version that has the angle that we know. So since I called this angle A, I want to use the first formula since I know capital A and I know little b and little c. Notice that actually I know everything on this side of the equation. The only thing I do not know is A. So let me go ahead and copy down the formula again. And a little memorization tip for you guys. This is how I have these formulas memorized. Based on kind of the structure. First, I remember the Pythagorean theorem. So essentially it starts with the Pythagorean theorem for any of the three combos, A, B, and C. But there's this new term, which is always minus 2 times the two of the sides. And notice that the two sides that are multiplied in this are all the same letter as the b squared plus c squared. And notice here a squared plus b squared minus 2ab. So basically it's always going to be a squared is equal to the other two squared minus 2 times those other two, because this is just the inner product of that factor that we looked at in the proof in the previous video. And notice that the cosine is always matching the angle to the side, which is on the other side. So if I started with a squared, it's going to always have cosine of the same angle A. Notice b squared cosine B, c squared cosine C. So if you remember those little things, that there's Pythagorean theorem minus 2 times the same things, cosine of the other side, that's kind of an easy way to remember it, and that has worked for me in terms of, having this formula in my memory so I don't have to look it up. But anyways, what I have is that x squared is a side I don't know is A. I do know that side B is 10, so 10 squared is 100, plus c squared is 981, minus 2 times B times C times the cosine of 47 degrees. And that's going to be approximately root 2 over 2, because it's close to 45 degrees, but that's something where I'd want to use a calculator in order to figure this out more exactly than I could without one. So let's pull up the old calculator, and basically I could run through each of those components. It looks like my calculator is not working for some reason. So I'll go ahead and just type it into Google and try to figure out why that's not working. But I have 100 plus 81 plus 2 times 10, minus, of course, 2 times 10 times 9 times the cosine of 47. And just as something for Google, if you're typing a mathematical formula in Google, I would make sure to put degrees in the cosine, just like how you would need to make sure your calculator's in degree mode when you're operating with degrees in your triangle. But anyways, what that says is that uh, that all comes out to about 58.24. And so going back to my other tab, this would be x squared is approximately 58.24. And of course, I would need to take the square root of both sides to solve for x. Or again, to find the third side. So x is now approximately the square root of that answer. So I could just put this all into a square root, like so. And that would give me about 7.63. Whoops, not that. Approximately 7.63. Again, ignoring the negative answer because it's obviously a positive solution. And now looking at this triangle, one of the things that I was talking about when we were talking about triangles before is our answer should always pass the smell test, meaning that the answer should make sense. And if I'm looking at this triangle, this answer seems a little bit fishy because it doesn't smell right. Because if I'm looking at it, well, this side appears to be the longest side, but as my answer indicates, it seems to be the smallest answer. But if I actually really examine it closely, 47 degrees, this angle A as it's presented is clearly not 47, right? That looks like it's closer to 70 degrees or something just from eyeballing it, or some around there. So that first of all, this triangle is not drawn correctly. So like I said before, sometimes when you see triangles, if they're not drawn right, then the answers aren't going to make sense based on visualizing them. So what we could do is try to imagine this triangle in a better context, in an angle which actually had a 47-degree angle. And actually notice another silly thing about this triangle is C is 9 and B is 10. Well, clearly C is longer than B, so this doesn't make any sense at all. And if we were to make a triangle where we had the side up here be longer then because B was equal to 9 and B was equal to 10 and C was equal to 9, it would look a little bit more like this in terms of what my triangle would look like. So side A, which is what we get x, in this case, our answer, it seems more accurate, when I'm actually drawing the triangle correctly. So take some of the diagrams in the textbook or in the packet with a grain of salt, just because they're not drawn well. And, it's probably my fault. I probably should have studied them a little bit more carefully. But it brings up an important point about how these formulas make sense. And if it doesn't pass the smell test, just really think about why that might be. But in the case of drawing it correctly, if I was to actually use pencil, paper, and a protractor and a ruler to design these triangles, it would be exactly right. And you can trust the law of cosines over your diagram. But when the answer is not coming out correctly, it's a good indication to maybe check your math, make sure that you did everything correctly. And a last little reminder here is we're really not done solving a triangle, even though a lot of times it might just say find x. But really there's still two unknowns in this triangle, the two angles. And to completely solve a triangle, we need to do those as well. And then the question you might be wondering is, well, what do I do now after I've solved that third side, side A? How do I find the remaining angles? But notice that once we have finished with the law of cosines once, we now know the combination of angle A and side A. And once we know that, the law of sines is always a little bit easier. Technically, you could continue to use the other formulas for the law of cosines. You could use this one and this one to solve angle B and angle C. But the math in the law of sines is a little bit easier. So what I'd recommend is once you've solved one pair from the law of cosines, you can then jump to the law of sines. And a lot of the time you can use either one, and it doesn't really matter which one you use. But there's very specific cases where you can only use the law of sines or only the law of cosines. Here, it could be either one. But basically, I would have sine A over A is equal to sine B over B. and that could give me angle B. And once I find angle B, I could just use the interior angle 180 principle. So I really don't need to do the law of sines more than once. And I'd always recommend doing the easiest way, because, easier is better. And basically start with law of cosines, then move to the law of sines, then you're done, because you can just use 180 principle. But basically I could multiply across by B like that, and take the arcsine to solve for angle B. And so basically angle B would be equal to the arcsine of B, which is 10 times the sine of angle A, 47, divided by sine A, which is 7.63. And doing all that in a calculator, again, I'm going to go to Google since my TI is not working on my computer right now. But the arcsine of 10 times sine 47 degrees divided by 7.63. I'll use a few more digits since I have them right there from my previous calculation. But that would leave me with 1.28 radians, which is in radian mode, and I could convert 2 degrees by taking that and multiplying by pi over 180. 180 over pi. And we usually want our answers in degrees. But if you have your TI-84 or 83, if you have it in degree mode, it should give you your answer in degrees already. But I'm going to go ahead and convert to degrees, which is 73.4 degrees. And I'm going to ignore the radians because I converted. Sorry, that was 73.4 degrees for angle B. And that gives me this angle right there. And again, it appears to be about right. It passes the smell test when I have a properly drawn triangle. And now that I know two angles, angle C should just be 180 minus the others. So if I do 180 minus 73.4 minus 47, whoops. It's okay, Google understood that because in some other countries they actually use the comma for the decimal point. But that would give us 59.6 for our third angle C. And our triangle is now completely solved. And down here, it doesn't look very good because I've used my poor artistic ability to sketch this triangle. But it seems to make more sense because the smallest angle is paired with the smallest side, medium angle, and largest side with the largest angle. And there we have it. In the next video, we will do one more. This one we referred to as a side angle side example. In the next one, we'll do a side example, which is the same kind of idea, but there's a little bit of different math for how we solve the law of cosines to begin with.